Coordinate geometry. Alright, we've got some hopefully review vocabulary for some different shapes. So a quadrilateral is a figure with 4 sides. A trapezoid is a quadrilateral, so a figure with 4 sides that has one pair of them being parallel to each other. Parallelogram is that quadrilateral, so the 4-sided figure with both pairs parallel to each other. Okay, so we've got 2 sets of parallel sides. And then our last vocabulary word is midpoint, and that's just the point that's exactly halfway between 2 other points. All right. So let's start with concept 1, using coordinates to classify polygons. So in this chapter so far we've learned, well, the distance formula is not from this chapter, it's back from chapter 3, but we know the distance formula. We've learned angle definitions, so acute, obtuse, right, and then we've learned a lot about triangles. And so we're going to use that information to properly identify figures that are either graphed for us or that we're given the vertices for. Okay? And you don't always have to graph out the vertices. Okay? Obviously, if you're asked to graph them out, you should, but just looking at the coordinates will a lot of times give you a lot of information about what it's going to look like on the graph. Okay. For instance, I look at this, I see 3 points. If there's 3 points, there's going to be 3 sides. So this is going to be a triangle. Okay. And then when I'm looking at these, I'm also looking to see points that they have in common. Okay, so this point and this point share the same x value. Okay, and if they share the same x value, that means one of them is going to be above or below the other. Right, they're going to be on the same x line. So let's go ahead and plot these ones. So 7, 1, 2, 3, 4, 5, 6, 7. Oops. I don't want that one. But 7, 1, 2, 3, and 7, 1, 2, 3, 4, 5, 6. All right. So those share that point. And then these two I see share a x value, right? Or sorry, a y value. So they're going to be on the same horizontal line. Right, so this one's going to be at -1, 1, 2, 3. And even if I hadn't plotted those, I should be able to recognize that these 3 points are going to form a right triangle. Okay, and the reason I know that is if I've got one point that's on the same horizontal line as another point. Okay, these two form a horizontal line. And that same first point shares a vertical line with my other point. I'm going to get a right angle. Okay, and if I have any right angle in my triangle, I'm going to have a right triangle. Okay, and if I went and finished drawing it out, you'd be able to see that, yeah, that's definitely a right triangle. Okay, let's go on to another one. So for this one, it doesn't have 3 points. It's got 4 points, so I know it's not going to be a triangle. All right. I do see that it's got some points in common. Okay. And then, oh, not that one. Got to be careful because that's a y value, a 3 for a y value, and there's a 3 for an x value. But I do see that I got these two in common as well. Okay, so these two are going to be in the same vertical plane, and these two are going to be in the same vertical plane. If these ones are going straight up and these two are going straight up, that looks like I've got at least one set of parallel lines. Okay, so I know I'm not just going to have a quadrilateral. Okay, it's either going to be a parallelogram with 2 pairs of parallel sides or a trapezoid with 1 pair of parallel sides. And if it's a parallelogram, it might even go more specific. It might even be a rectangle or a square. Okay, you always need to classify them by the most specific name. Okay, so let's plot these out. So I've got -2, -2, and -2, 3, and then I've got 3, -5, and 3, 1. Okay, so I'm going to grab my line, draw my lines out. And that's okay. If I look at this, it looks like, I mean, these are definitely parallel. These vertical ones, just like we saw earlier, those are definitely going to be parallel. It looks like these ones might be parallel, and the best way to look at them and tell is to look at their slopes. Okay, so this one comes down 2, right? So the rise, -2, and it's going to come over 1, 2, 3, 4, 5. Okay, and this one's going to come down, down 3, and it's still going to go over 5. Okay, so I've got different slopes. So these are not parallel. I don't have a parallelogram, okay, but I do have one set of parallel lines, so it's going to be a trapezoid. Okay, so I've got a trapezoid. All right. Okay, let's look at the last one, and we'll try and be quick with it if we can. So you should be looking at it. You should say, okay, how many points do I have? I'm given 3 vertices, so I know this is going to be a triangle. Now, does it have any points in common? 4, -6, -1, nope. 1, 2, -5, no. So it doesn't have any points in common. Now, that doesn't mean that it can't be a right triangle, okay? But it does mean that it's not going to have points that are in the same horizontal or vertical plane, right? We could have a right triangle that forms its right angle, something like that. Okay, this is still going to be a right angle, right? But let's go ahead and plot this one out since we can't really tell. So 1, 2, 3, 4, 1, 1, 2, 3, 4, 5, 6, 1, 2, and 1, 1, 2, 3, 4, 5. Okay. All right, and I'm going to draw some lines so I can see how things are shaping up a little bit better. And okay. Well, looking at this, I think I can safely say that this is going to be a scalene triangle. Okay. Because none of these sides look even. Okay, it might be kind of close to an isosceles triangle if this point was up here or something like that, or maybe even down here. But this doesn't look like it's close enough that I have to worry about it. I can tell just by looking at it. Okay, so I'm going to say it's scalene. Scalene. Because all the sides are different lengths. Okay, and the last piece of information I need to know is this an obtuse or an acute scalene triangle? Okay, and this corner looks like it is going to be acute. This looks like that's my largest angle, but I think that's an acute angle. So I'm going to say that this is going to be an acute scalene triangle.